just to cater for high vehicles. So that is where that's why I put in a slide for areas for improved design of parapets. So if we can convince the authorities, we can tell them, look, nowadays vehicles are much higher. So don't do 1.1, try to go for 1.4, 1.5. So if they can have the budget, then it's okay. But legally, sorry?
In this Penang Bridge punya event yang refer to the yang purple tu, any suggestion we come out suggest to the plus for the improvement.
Okay, you see, what happened was, FND.
This one just for sharing lah.
Yeah, just for sharing. It's just for sharing. We can't suggest, you know why? Because it has been designed as per BS 5400. So the international code itself, they have not revised it. So the government says that bridge have been designed for BS 5400. So it's only designed for normal containment. So they should have, in those days, they should have said, design
maybe due to safety because of the the case or the happen kan.
Yeah, correct. True. But then now you see, supposing, okay, now this is a normal containment, right? 900 something and 100 something, okay? If we go for higher containment, this block will be much higher and big. Am I right? This block will be much higher and big. It will go up easily up to 1.5 to 1.6 meters high. Okay, now for bridges which have already been allowed for normal containment, when you want to change it for high containment, it's very difficult because the beam below this may not be able to take the impact load. The beam. Okay, now you see here, this is a normal containment parapet rail. Now, if say like for Penang Bridge, I want to upgrade it to become high containment. I do a bigger structure here. Okay. The bigger structure will protect the vehicle from being overthrown into the sea or river, whatever. But the beam below may not be able to take the forces arising from a more
additional load lah.
Yes. So you have that situation. So this is normally has to be done during the design stage itself.
Yeah.
That's the problem. I mean, you can provide a higher parapet, but the beam can break. If it's a U beam, I'm still okay with it. U beam can take more because U beams are normally quite big. But Penang Bridge, we don't have U beam. So on the original bridge, so if you have like I beam and all, then the beam koyak already. So your parapet is good, but your beam koyak already. So you cannot lah.
In this case, need to go back to the owner of the design lah.
Yeah, but if I mean, like you see in Sarawak, you have all these bridges with crocodiles and all. I don't know. Even though the BS code may say,
banyak crocodile.
Yalah, banyak kan buaya. So even though BS code boleh kata normal containment is okay, but I don't know. Just please don't quote me, but just that you got a lot of crocodile, better go for higher containment. Betul kan? Better go for higher containment. Nanti tenggelam kena makan buaya habis. So that is the problem we have. So that's why I said
during construction also have to protect,
Have to protect kan? Buaya banyak.
Buaya banyak.
Aduh. So tak boleh buat underwater inspection lah.
With proper barricade lah, proper protection lah.
Must lower
because
down.
We also facing high tide, low tide, but have to come up with proper cage lah.
Must have a proper cage lah.
Especially when the packet work lah.
It'll be more costly lah. You know?
Yeah.
So this is an area of improvement. So in the future, if you're engineers, you are involved in some kind of design, you see that the needs, you can always propose to the authorities, come on, don't go for a normal containment. That is based on 1970s. Nowadays, the vehicles are much higher and the vehicles are also much faster. Remember the video we saw on the Penang Bridge? They were traveling so fast. So go for higher containment. That'll be better. Okay. And containment values, you have TL1, TL2, TL3, TL4, TL5. TL stands for test level. So you can Google and study or refer to some books. What is TL1 to TL5? So the normal containment is under the test level is called TL3. So if you can't go for TL5, TL5 is a heavy one. This is TL5. The 30,000 kg is TL5. You can't go for TL5, you can go for TL4. This is TL3, test level 3. Normal containment is test level 3. So if too expensive to go for TL5, can go for TL4. Many bridges, when I commented for plus, for the new ones built by third party, I asked them to go for higher level of containment. At least go for TL4, at least for 10-ton vehicle. Okay, now we look at bridge management system. Like what I said, for bridge engineering, the first part was in terms of the type of crossing, whether you want to use a T-trunk or whether you want to use a beam, whether you want to use a box girder, and so on. The second part was in terms of loadings, what kind of loadings you want to consider. And the third part was in terms of parapet and so on. Now we look at bridge management system. This is normally is used for maintenance. So what is bridge management? Why is the bridge management system required? So it's to ensure the satisfactory service of the bridge. You must maintain it at all times. Just because bridges are designed for 120 years, and the 120 years is only valid if you do proper maintenance. If not, it will not be 120 years. So the BMS is also required whenever, because you can have aging, you can have change in traffic loading. Dulu design untuk HB30, sekarang kebanyakan vehicle yang lalu adalah lebih daripada apa ni 100 tan or whatever lah, okay. So deterioration from weathering and mungkin dulu sungai dia adalah tak berapa lebar, tetapi sekarang sungai dia adalah lebar. So you have an extensive change in channel capacity. Betul tak? Because due to urbanization, your river can also become wider. So you got to change. So you need a management system. You need to inspection, management system, you have inspection, you have maintenance, you have rehab, you have improvement and so on. Okay. Then you can have scour, you can have marine growth and damage due to accident, earthquake and so on. So these are the components of bridge management system. Okay. So what is bridge management system? Bridge management system, you have collection of data, you have storage of data, and then you do your whatever ratings and your planning for future work. Then you optimize the budget and you have your planning for repairs and upgrading of bridges. You need to upgrade certain bridges. Dulu design untuk 80 tan, sekarang nak design untuk 120 tan, terpaksa kita upgrade. Dulu design di mana sungai dia adalah cetek dan tak berapa lebar, sekarang sungai adalah lebar dan dalam, so have to upgrade. So this is basically like what I told you just now. This is our understanding on BMS. So road user safety, serviceability, and durability. This one I think generally all of you know about this. So nothing much. It's just how to maintain it in a good way. Targets. What's the target of BMS? The first target, we want to prevent structural failure. We do not want any bridge to collapse. So to avoid any bridge to collapse, you must have a bridge management system, which doesn't mean that you have a computerized system. No, bridge management system doesn't mean you must have a computer software. There's no such thing. How about 50 years ago, 40 years ago? At that time, they didn't have computer software, so but still can do the BMS. It has to be done manually, lah. So we have, so to manage a bridge, you must have inspection. So
Mr.
from the
Kumar,
inspection results,
can I
from
ask
the inspection,
something?
yeah, can.
Okay, for the bridge inspector, is there any qualification for that?
Okay, all right. So now we need to look at the guidelines related to bridge inspector. As per the guideline, the bridge inspection process, the bridge inspector must have some knowledge on bridge inspection. Generally, people who have diploma or certificate in civil engineering should be good enough to do the bridge inspection. Okay, but the bridge inspection manual also says when there is a defect has been found which requires further investigation, a person from the HQ or the office has to come down, and that person has to have minimum 5 years experience on bridge design and in the design of bridges. So there is two category of inspector. The first category is the person who does the bridge inspection. Generally, they should have a certificate or diploma in civil engineering or trained for bridge inspection. If they don't have both, they must have been trained for bridge inspection. Probably they have worked in some authority or something, they have got some experience. It's okay, but they should have been trained. But the second level is very important. That person, whenever you find defect ratings of a certain extent, like, oh, defect rating, I got defect rating 4 and 5. So to do the defect report, you must have a person with minimum 5 years of experience in bridges. So that answer your question?
Oh, yes, thank you.
Yeah, who was that? That's how I can't see your name because I've seen on the slide.
My name is Arbi.
RB, okay. So RB, it's important that the inspector is either certificate or diploma. Kalau dua-dua pun tak ada, must have some experience, because we can't deny those people who do not have the papers, but they have a lot of experience. Maybe the guy worked in JKR Bridge Department for 10 years. He's still fit to do the inspection. It's okay. But when the defect rating is higher, the person with 5 years experience must come down. Okay. So the second thing, yeah, okay. Now the second thing why we do inspection is to prevent magnification or repair cost. Today I repair is 5,000. Then I don't do inspection and maintenance. That repair cost may become 50,000 in a couple of months' time. Okay. And third is to plan and forecast maintenance budget. Okay, this for river, channel, and traffic. And of course, the other target is to schedule inspection and frequencies. This operating environment, you have a lot of traffic, you have factories and all. So maybe you want to reduce your inspection interval from 2 years to become 1.5 years. So all this, you can play it around as to suit the condition. So the BS guideline is only a guideline only. It says, oh, you must do your inspection every 2 years. It's okay. But if I have some bridges in bad condition, I can always reduce the frequency to become yearly, right? Now this is for BMS. Generally for BMS, you need to develop the inventory and you have a data collection drawing, and you need to set your target. That means I want my bridge to be in good condition in this way. I do not want defect rating more than 3 and so on. So, and then we do the general or periodic inspection. So then you have your budgeting, and then you have your work program, and then you award the contract or work order to repair. Okay, basically it is collection of data, as-built, whatever, and to have the inventory, and then later to check what is the requirement, Then moving on for inspection and to look if there's any serviceability gap which have been given by the owners. Probably in that particular place, LLM says, I do not want any your bridges to have any defect 4 or 5. Okay, so we have to look at that if there are any requirement, and then you have the work program, and you have implementation of works. This is a modern day BMS where you can have your database and people using the computer to store data and process your things. But this computer aided, but BMS itself does not mean it has to have computer. Like what I said 40 years ago, you still can have BMS. The meaning of BMS doesn't mean that it has to be computer based. Okay, type of
Mr.
structure.
Puvalan?
Yeah, yes. Okay, yes.
Yeah, sorry.
Okay.
Yeah, I have a question.
All right.
In Sabah, it's Linda here.
Okay, yeah, Linda. Yeah.
So in Sabah we have lots of belly bridge.
Okay.
So the common problem I saw at site is the runner board, which is supposed to be a type A hardwood.
Okay.
They are not, I think, not reliable because less than 1 year already rotted. So do you have any recommendation on any other materials to replace this hardwood?
Okay. Now the Bailey Bridge basically is a steel frame, right?
Yes.
It's a steel frame. Your runner board is only on top for the vehicles to move and so on. Am I right?
Yes.
Okay. Well, it's supposed the good wood would always be chengal. You know chengal wood?
Yeah, but nowadays we don't have much hardwood anymore.
Yes.
So I think we have to seek for other alternative. But that is whether you have any recommendation on good alternative materials.
The good material will still be another steel member to be retrofitted to your frame, because you see, and then you can have a checker type of member on top. You can't have a checker plate, large checker plate, because Bailey Bridge is normally designed to be dismantled, right?
Apparently in Sabah it's not
permanent.
Yeah.
If it's permanent, then you can go for checkered plate. You can go for steel plate, which has got friction over it. You can take out the woods and replace it with checkered plate. That can be designed for. Is that okay?
Okay. So only checker plate, any other things? Because I was in Tawau last time. So one of the DE he wanted to replace the timber floor the runner board using a checker plate. But I'm not sure why actually it's not been used widely. So maybe is it because of maintenance? I'm not really sure about that.
The way I look at it, because when you have, you see, the Bailey bridges, like what I said, the primary function that it can be dismantled. So if they use checkered plates, then the number of joints will be less. So you have members which is more larger to dismantle. So you may have a checker plate area which is about 3 to 4 meter length and 3 to 4 meter wide. So then you need to remove it. So that is probably why they found that using the timber members is easier to remove, and also, you know, some flexibility on the timber. But then for durability, you can move on from timber to have checker plate, but you can't use any concrete or what due to the weight. So you have to go for a plate member, because the concept of a temporary bridge, of course, here Bailey Bridge, you are using it for long term. It's called Bailey because you have all the steel frames and so on. So it's best to have the checker plate. What did the engineer say the other day? Are they okay with the checker plate or what? Or do they have any other suggestion?
I heard that they are using something maybe it's a polymer or something because the checker plate is not, there is no tidak begitu mendapat sambutan lah.
Oh, mendapat sambutan. Okay. That's why I said mungkin you boleh buat, mungkin you boleh gunakan fiber reinforced precast concrete panel. Tetapi it has to be designed for. So kita terpaksa jumpa dengan satu company yang ada sejenis apa ni, sama seperti railway sleeper kan, yang konkret tu, tetapi dia adalah lagi tegar sebab dia ada fiber reinforced, specially produced. Yang ni pun kita dapat bolt dekat atas, tetapi kita terpaksa check untuk friction lah, untuk friction dia supaya bila orang brake untuk skidding, the friction coefficient must be enough. There is no problem whether you want to use checker plate or you want to use a precast concrete panel or you want to use some kind of cement board. It's all right. But the most important thing is the friction coefficient. Remember last time when we designed for friction, the formula is F is equals to mu R. So the value of the mu is very important. Then you know that plays a role lah. But generally, when I did temporary bridges before in Sungai Kantan and so on, Mersing, so we use checker plate.
Okay, thank you.
So there is no exact answer here, Linda. You can use checker plate, you can use precast panel, precast concrete, you can use whatever fiber, depend on what supplier you want to promote. But the important thing is the coefficient untuk geseran mesti cukup.
Okay.
Okay, right.
Thank you.
Yeah, welcome. So BMS web-based design. Okay, so this ada BMS Okay, structure defect ni kita pergi laju sikit. Crack on structure member, more likely on beam which is more than 40 years. Okay. Micro crack is crack yang sangat halus. Yang pier yang crack. Okay. Ini biasa untuk pier yang cantilever keluar. Di mana kawasan ni is under bending arah ke bawah. Jadi kawasan di atas ni adalah bawah tension. So it's likely to have some service crack. It may not be serious crack, but it may have service crack because untuk jangka masa yang lama. Okay, mostly noted. So kalau crack adalah bawah 0.025, generally is okay lah. 0.025. The maximum crack width allowable is 0.3 mm. What I put the limit here low because kalau kurang daripada ini, air tak boleh meresap ke dalam. Kalau kurang daripada 0.025, air tak boleh meresap ke dalam. So what happen when more serious cracking is found? You may do remedial work and proposal for retrofit. Sama seperti middle ring road di mana mereka gunakan carbon fiber untuk retrofit middle ring road. Okay, this is for middle ring road lah. Saya just buat satu sketch yang biasa. Tapi kalau kita lalu di bawah middle ring road yang ada sekarang dekat kawasan KL, kawasan Kepong dan sebagainya, kita dapat lihat ada carbon fiber. So what they have done, they actually retrofitted. So there must have been some kind of capacity problem. Okay. Now lateral movement of bridge deck. Okay, this is the case where it's quite common. I'm not sure about in Sarawak, but then here I came across many bridges. Not only this one, it's also in JKR as well. So we have a walking bearing. They say the bearing walks actually. Okay. Original walking bearing is where the bearing displays from its original position. Now we'll see why this happens. Okay. So generally this walking bearing is due to inclined forces from resolved vertical load. So when you have a flat bridge where the deck is not tilted, so you do not have any horizontal component. Sama seperti kita apabila kita bawa basikal dekat kawasan yang apa ni curam dan sebagainya. So basikal tu akan gerak sendiri sebab kita ada komponen gravity yang turun ke bawah. Okay. So the same thing is that when you have tilted deck, you will have some component forces. So like here you can see you have a inclined component or horizontal component. This is something which can push the bearing out. Right? Now, the question is, if this is the case, then why didn't the engineers allow for the design to be this way? Am I right or not? I'm sure the engineers who have designed the bridge have already known this situation. So basically it boils down to the design of bearings. Okay. So the design of bearings, the BS code says that the friction of the bearing is good enough if the horizontal components is less than 0.1 of the total vertical load. This is when you do the design of the bearings. So the bearings itself can accommodate this, but to a certain extent, where the horizontal component must be less than 10% of the vertical load. Then the bearing is enough. But if the horizontal component is more than 10%, or the friction of the bearing changes in time, mungkin bearing kena air ke atau ada masalah buat dekat kilang ke apa kan. So then the friction dia kurang, capacity dia pun sudah kurang. So then the bearing will slide. So that is how the thing is lah. So the engineers know about it. They have allowed for it, but due to some effects on the bearing have lost its friction and so on. So then it can move on. The friction coefficient, this is the friction coefficient mu. This is what I was talking about just now for the checker plate or whatever you want to use. You can use whatever you want as long as the friction coefficient is good enough so that the vehicle does not skid. So as long as the horizontal component is less than 10% or 0.1 of the V, then your bearing is workable lah. Then supposing the bridge slides. So what do we do when the bridge slides? So we have to protect it from sliding down. And that can be done by constructing a shear block. Shear blocks are very useful. Shear blocks can protect the deck from sliding down. Example of shear block. Shear block has been done here. No shear block, but restraint tiles. Okay. And another good way to do design of bridges is to allow some space for bearings. I've came across certain bridges where they have not allowed for space for jacking. So that's a problem. So better when they design, in bridge engineering, it's better to design for bridges which we have some space for jacking. So how to improve the design? All right. So improve the design by allowing some space to jack. Okay. If I don't have some space to jack, then I must do a temporary support to jack the bridge. Now this becomes costly. And what if when I fix a temporary support to the pier cannot, this part of the pier cannot take the bending. So I have more problem. Am I right? I came across situation like that, where we wanted to fix a temporary support to jack the bridge, but we can't even fix the temporary support because the pier, this part of the crosshead beam cannot take the bending. Okay, so what we do is, we even need to erect another structure going on top. So it becomes very costly. Okay. How to improve? Allow proper space for bridge jacking, and jacking done at one end of the diaphragm. This is an example where we are doing some bridge jacking work. How else we can improve? In Malaysia now we have integral bridges. Integral bridges are bridges where rubber bearings are no longer used. So they cast all the beams and the pier together. Then where is the movement allowed? When you have structure, you will have movement, right? I mean, due to vehicles moving and dynamic load, your thermal expansion and all. So the movement is allowed at the abutments. Okay, this is for integral bridges. So you have nowadays you have bridges coming up as integral bridges. You do not have bearings below. Now the setbacks of integral bridges, I've just written this, but I'm not sure because there is not much of write-up I see. But what I can forecast is that if we have any problem with construction doing this abutment, if it's not flexible enough, the abutment, then this structure will be very stiff, no movement, and expansion or contraction may cause some cracks at where the bearings is supposed to be. I don't know, but we have not seen that yet. So, but integral bridges are new. Currently, there are bridges being designed and constructed as integral bridges. So, if integral bridge is not possible due to earthwork, then we have to use bearing. We can't avoid that. And friction, you know how we can improvise? The friction coefficient of the rubber bearing, we can increase it. Probably tell the factory to do a rubber bearing which has got more friction coefficient. All right, thank you. That's how that's the end of the presentation training today. I open it up for any questions. It's already 1.5 hours. Any questions across the floor? Any questions? Anyone? So if no question, then we have come to the end of the presentation of bridge engineering. I hope that has been quite useful, and and also there will be more upcoming training from me. I've planned some training next year, which is for appraisal of structure level 2, and there is also another bridge inspection training tomorrow. So if you're free, you can join tomorrow morning at 10 o'clock. But that is basically only on bridge inspection and ratings and so on. So people who are involved in bridge inspection are most welcome to join the training session tomorrow. Okay. Apart from that, I'm not sure how the attendance is taken. hope that it's recorded and
Baru nak tanya.
macam mana dia punya form tu? Dia orang pun tak bagi saya lah form tu.
So any apa point dalam kita punya ni
Mesti.
ke?
Kalau you tengok dalam saya punya email tu, ada satu link bawah sana dia dalam Oracle. Dalam Oracle mereka sudah rekodkan training ni.
Yalah.
Just click on that lah. Am I right? What I spoken to them, according to them, is automatically calculated.
How it happened yesterday? How they arrange?
Yesterday also the same thing, FND. I did, but they didn't give me any form. I emailed to them, asked them for the form. They haven't given, but what they replied me, remember, if you see my email, my invitation, there's one icon there. Click here, right?
Oh yeah. Click here.
You control click. You need to control and click.
Yeah. Have to register here lah.
You have to register there, is it?
Yeah. No, I think this one just direct to kita punya page itulah.
Dia direct kepada you punya Oracle sendiri kan?
Oracle course offering detail yang apa? Enroll lah. Oh, just click button enroll lah.
Tak pasti. Saya tapi anyway, you all have already attended this training. It's also recorded dalam team kan?
Yalah.
Better to email to them and say they have to put the points in lah.
Who's the organizer?
Organizer under the training academy is this.
Maybe you can email them. Whoever the organizer can email them.
What Yusmanizam was trying to do for me yesterday was trying to get for me the list of attendees. Yusmanizam, were you able to take down the list of attendees?
Boleh.
Boleh kan? Okay, give me the list of attendees. I will send it to Agenta Academy.
Okay.
Agenta Academy, the person in charge is this apa ni? Wait. Normally I deal with. I deal with this Dahlia binti Minhat, and also another person, Nur Hidayah, I think. Yeah, so I need to email to them. I also want you all to get all the points, you see, and also for myself also.
Itu rugi tu.
Rugi tu kan?
Tak dapat.
So the person is actually Dahlia lah, Dahlia. So yang penting ni sekarang adalah attendance list dalam ni. Kita terpaksa dapatkan attendance list. So Yusmanizam, give me the attendance list. I will email to Agenta Academy. Fendi, you want to know? I mean, for all the attendees, the person in Agenta Academy is this one Dahlia. I'll try to contact her later. So if you all can just keep for your record, is Puan Dahlia binti Minhat. Okay. So I will email also lah. Okay. All right. So if there's no questions, then I will end the training today. Fendi, is that okay? Yeah, okay. So thank you very much for all the attendees. So I hope that the knowledge which you have gained here, you can use it in your work. And I'm always contactable, through Encik FND, and also you can see my name. So you can always email to me if you have any queries. Okay. Thank you very much. Have a good day. Bye.